Okay, the objective in this lesson is students are going to describe the rigid motions needed to map congruent figures, to map one figure to the other. So we've previously defined congruence as having the same size and shape. And then when we know that they're congruent, we would write a congruent statement. So if I look at the two triangles here, and if you see, it looks like AB would match up with EF and CB would match up with DF. So if I start with, actually I can start marking them up. It looks like A and E would go together, B and F, C and D, and then the sides you could mark up. And then my congruent statement would be triangle ABC is congruent to triangle EFD. Remember, you have to have correspondence. So A corresponds with E, B with F, C with D. And that would be my congruent statement. So we have another way of defining congruence. And we can say that two figures in a plane are congruent if a sequence of rigid motions can be used to map one figure to the other. So remember, our rigid motions are translations, rotations, and reflections. So using these three rigid motions, sometimes you only need one. Sometimes you'll use a combination of each one, but you'll never use more than one of each. So here's an example. Given triangle ABC is congruent to triangle DBC, so we know that they're congruent. Describe a rigid motion that would map ABC to DBC. So if you look at the picture here, I first look at the orientation of the letters. So ABC is, what's it called, counterclockwise. DBC is clockwise. So if you can't just tell from the picture, that is an indirect isometry, so that means there's going to be a reflection. And really, if you can visualize this, if I can reflect ABC over the line BC, then A would map to D, B would map to B, C would map to C, and they would map to each other. Okay, so to describe that, you could say it in words. You could say reflection, or reflect over BC. Okay, you could also say it in symbols, just lowercase r BC, and that is sufficient to map one to the other. Okay, in our next example, triangle TRS is congruent to triangle TUV. Again, we're going to describe a rigid motion that's going to map one to the other. We start with TUV and we go to TRS. So if we look here, this time TUV is clockwise, TRS is clockwise. So, not a reflection. In fact, it looks like it's going to be a rotation. If I take this and I rotate it around, V is going to map to S, U is going to map to R. Okay? So this is going to be a rotation. And if I look at how many degrees, it's going to be 180 degrees. About T. So you have to name the degree amount, and you need to tell me the center of rotation. In symbols, it would be capital R, T, comma, 180. Either one of those would be sufficient to answer the question. So those examples were using a single rigid motion, but remember, we can also use multiple rigid motions. And when there are multiple rigid motions, remember again that there can be at most a sequence of three, one of each type, to map one congruent figure to another. So here's a couple of tips to figure out how to do this. I would translate first, so you map a point to its corresponding point. Then you would check the orientation to see if you need to reflect your image or not. And remember, checking the orientation meaning is to check the order of the letters, because if the direction flips, that means you need to have a reflection. So once you translate and reflect, then you finish with a rotation if you need to. So here's an example of this. Give a sequence of rigid motions that maps M and Q to W, X, Y. So what you would do is I would map M to W. So I would translate it, which means you would translate using a translation vector MW. And then I would check the orientation. So if I look, M and Q is going counterclockwise, WXY is going clockwise. So I would then reflect it. So the next thing you do is you reflect it. And here you could say just reflect over a line. Over a line through M. And then once you reflect it, you'd have to rotate it in place. And then you would rotate about M. So depending on the problem, this one is a little bit more complicated because there's no room to work here and to sketch it out, and it's not very accurate, but we'll do some more in class where it's a little bit more accurate. Or sometimes you get a coordinate grid, which will be the next example. But when you have something like this, you need to be as accurate as possible. You know, you're going to translate M to W. I don't know if this will move for me or not. No, the whole thing will move. Sometimes I can move an object. So you would translate it, and then you would flip it. So once you flip it, if I just try to visualize that, if I flipped it over M, then he would kind of, M would be there, and maybe he looks like this when you flip it, something like that. Oops, no, not that. I gotta flip it. I didn't flip it. If I undo, okay, so let's do this again. So I transfer it, I flipped it over, and it would be kind of like that. Okay, so once I translate and flip it, this is N prime, this is Q prime, then you could see you would rotate it in place, just like that, and they would map to each other. Okay, so when we have a grid, we can more accurately do this. So I want to map ABC to DEF. And there's a lot of different ways you can do it. I would first translate, just to go in the order that I told you, I would translate A to D. Okay, and then I can sketch that because I have the grid to do it. Okay, so there's my triangle after I just translated it. So I translated using vector, you could say vector AD, or you could actually put the numbers in here. That's equivalent to T. So I moved it 14 to the right and 6 up. Okay, there's my translation. And then I need to map C to F and B prime to E. Well, if you look at it, if I just reflect it, I can reflect it over this line, 1, 2, 3, 1, 2, 3, and you can see that these guys are the same distance away, and these guys are the same distance away. So this line is 1, 2, 3, 4, 5. That line is X is equal to 6. So then I would reflect over the line X is equal to 6. Okay. If I put this in function notation, we would write it right to left. So the first thing I would do is I would translate, and then I would reflect. I don't know if that shows up very often on the Regents exam, but that's how you would write it if you wrote it in symbols. Or you could just write it out and say, you could write this and just put then reflect over the line x is equal to 6. You could also write it out in words. Either way, the point is that there is a series of rigid motions that can map ABC to DEF. Therefore, triangle ABC is congruent to triangle DEF. So we will look at a few more examples in class, but that's basically using a series of rigid motions to show that two figures are congruent.